March 19th, 1943. Imperial Japanese Navy General Staff Headquarters, Tokyo. Captain Tomioka Sadatoshi stood before a wall-mounted map of the Pacific, red pins marking Japanese-controlled territories, blue pins tracking American naval movements. In his hand, he held the latest intelligence summary from reconnaissance aircraft operating out of Truk. The document contained a single line that made his carefully constructed strategic calculations meaningless. American carrier count. Confirmed visual identification of 18 fleet and light carriers operating in Pacific theater. Estimated total construction. 27 carriers commissioned since December 7, 1941. Tomioka read the line 3 times. He checked the date on the report. He verified the source codes. The information was accurate. It was also impossible. 15 months earlier, in December 1941, the Imperial Japanese Navy had possessed the most powerful carrier force ever assembled. 6 fleet carriers, 2 light carriers, all modern, all proven in combat. The Americans had 4 carriers in the Pacific. The mathematics had seemed straightforward. Japan would destroy American carriers faster than American shipyards could replace them. Each carrier took years to build. Each carrier lost was an irreplaceable strategic asset. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The war would be won through attrition, through tactical brilliance, through the systematic elimination of American naval power. Except the Americans were not playing by rules that Japanese planners understood. They were not building carriers the way navies had always built carriers. They were doing something that violated every principle of naval architecture, every assumption about industrial capacity, every calculation about construction timelines. They were building carriers the way Ford built automobiles, on assembly lines, with interchangeable parts, using workers who had never seen a ship before. And they were doing it faster than Japan could sink them. Tomioka had joined a planning conference 3 months earlier, where Admiral Fukudome Shigeru, chief of the operations section, had presented strategic projections for 1943. The presentation included careful calculations of American industrial capacity based on pre-war intelligence, adjusted for wartime mobilization. American shipyards, Fukudome had explained, could theoretically produce 8 to 10 carriers per year at maximum capacity. That assumed every major yard dedicated substantial resources to carrier construction. That assumed optimal conditions, unlimited materials, no labor constraints. Even under perfect circumstances, Fukudome had calculated, America might commission 12 carriers annually for 1 or 2 years before resource constraints and competing demands reduced output. Over the course of the war, Japan's operations section estimated American carrier production would peak at 40 to 50 vessels total. This seemed like a conservative, reasonable assessment based on everything naval planners understood about shipbuilding. Japan had 6 major naval yards capable of building carriers. Each yard could produce approximately 1 carrier every 18 to 24 months under wartime conditions. Simple mathematics suggested maximum Japanese production of 12 to 15 carriers across 4 years of war. The Americans had more shipyards, more steel, more workers, but not infinitely more. A ratio of 3 to 1 or 4 to 1 American advantage seemed plausible. 50 American carriers against 15 Japanese carriers represented unfavorable odds, but not impossible ones. The calculations assumed traditional shipbuilding methods. They assumed carriers required skilled craftsmen, years of construction time, custom fitting of components. They assumed shipyards operated as they always had, with each vessel built individually from keel to commissioning. These assumptions were wrong. By March 1943, American yards had already commissioned 27 carriers. By December 1943, that number would reach 47. By June 1944, 72. The final count, when surrender came in August 1945, would be 124 carriers of all types commissioned during the war. 124 carriers. Japan built 17. The ratio was not 3 to 1 or 4 to 1. it was 7-1. And unlike Japanese carriers, which were increasingly kept in port due to fuel shortages and lack of trained pilots, American carriers operated continuously, launching strikes across the Pacific with numerical superiority that made tactical resistance futile. The story of how Japan miscalculated American carrier production by a factor of 3 begins with assumptions that seemed reasonable in 1941, but proved catastrophically wrong by 1943. These assumptions were built on decades of naval experience, on established shipbuilding practices, on everything the world's navies understood about how aircraft carriers were constructed. Aircraft carriers were the most complex warships ever built. They required massive hulls to provide stable platforms for flight operations. They needed powerful propulsion systems capable of 30-knot speeds for launching heavily loaded aircraft. They required extensive aviation fuel storage, ammunition magazines, repair facilities, crew accommodations for over 2,000 men. The flight deck itself was an engineering marvel, an 800-foot runway, built atop a moving vessel, equipped with arresting gear, catapults, elevators capable of moving 20-ton aircraft between hangar and flight decks. Every major navy built carriers slowly and carefully. The process required years of labor by skilled shipwrights, naval architects, specialized craftsmen. Japan's Shokaku, commissioned in August 1941, had taken 44 months, from keel laying to commissioning. Her sister ship Zuikaku took 45 months. These were modern carriers, incorporating lessons from a decade of carrier operations. 44 months was actually fast for a Japanese fleet carrier. American carriers before the war followed similar timelines. USS Yorktown, commissioned in September 1937, took 33 months to build. USS Enterprise took 30 months. USS Wasp took 31 months. The pre-war construction pace for both Japan and America averaged about 3 years per fleet carrier. This established a baseline that naval planners used for projections. If America wanted to build 50 carriers during 4 years of war, they would need shipyard capacity capable of starting 13 carriers per year while simultaneously completing vessels from previous years. The United States had approximately 7 major shipyards capable of carrier construction. Simple division suggested each yard would need to produce nearly 2 carriers annually. That seemed theoretically possible, but practically difficult, given competing demands for destroyers, cruisers, submarines, merchant ships. These calculations made sense in December 1941. They were logical, conservative, based on historical evidence and sound analysis. They were also completely irrelevant because they assumed American shipbuilding would continue operating as it always had. That assumption died at Pearl Harbor. The man who killed that assumption was named Henry Kaiser. He had never built a ship before 1941. He was a construction engineer who built dams and bridges. He knew nothing about naval architecture, nothing about traditional shipyard practices, nothing about how things had always been done. This ignorance proved to be his greatest advantage. Kaiser looked at carrier construction not as a naval problem but as an industrial problem. He saw a steel structure that needed to be assembled quickly, using standardized components. He saw an opportunity to apply mass production techniques that had revolutionized automobile manufacturing. He saw a challenge that could be solved through prefabrication, modular assembly, and systematic organization of unskilled labor. Traditional shipbuilders told him carriers could not be built that way. Carriers were too complex. They required custom fitting. They needed skilled craftsmen who understood the unique demands of naval construction. Kaiser ignored them. His first major contribution was escort carrier production. These were smaller carriers built on merchant ship hulls, designed for convoy protection and amphibious support rather than fleet actions. They displaced about 10,000 tons compared to 30,000 tons for fleet carriers. They carried 30 aircraft instead of 90. They were slower, more vulnerable, less capable in every respect than fleet carriers. They were also much faster to build. Kaiser's Casablanca-class escort carriers were constructed using revolutionary methods that shocked traditional naval architects. The hulls were prefabricated in sections at multiple facilities, transported to the shipyard, then welded together in weeks rather than months. Flight decks were built as complete units in specialized shops, tested and equipped with arresting gear, then lifted by massive cranes and placed atop the hulls. Propulsion systems came as complete modules, pre-assembled and tested, installed in days rather than weeks. Every component was standardized, every elevator was identical, every hatch, every door, every ventilation duct followed standard specifications. Workers did not measure and cut and fit each piece individually. They assembled pre-manufactured components like building blocks. The first Casablanca-class carrier, USS Casablanca herself, was laid down on November 3, 1942. The ship was launched on April 5, 1943. Commissioned on July 8, 1943. 8 months from keel to commissioning. For a vessel that could carry 30 aircraft across the Pacific and launch strikes against enemy positions. Kaiser's Vancouver, Washington shipyard eventually produced 50 Casablanca-class carriers. The average construction time was 8 months. At peak production, the yard was launching one escort carrier every 8 days, one carrier every 8 days. The Japanese naval staff received these reports and assumed they were errors. One carrier every 8 days violated everything known about shipbuilding. It was physically impossible to construct a floating airfield capable of operating 30 aircraft in 8 days. But Kaiser was not constructing carriers in 8 days. He was assembling carriers in 8 days from components built over previous months in dozens of shops across America. The keel might be laid on November 1st, but the flight deck sections had been under construction since September. The propulsion module had been assembled and tested in August. The island superstructure had been fabricated in July. When the keel was laid, half the ship already existed as completed modules waiting for assembly. This approach required massive industrial coordination. It required steel mills that could produce plates to precise specifications. It required fabrication shops that could build identical components repeatedly. It required transportation networks that could move 20-ton modules across the country. It required cranes capable of lifting complete flight decks. It required welders who could join sections with seams strong enough to survive combat damage and heavy seas. America possessed all these elements. The automobile industry had spent decades perfecting mass production techniques. Steel mills had been producing standardized components for decades. Railways could transport anything anywhere. Industrial organization existed at scales that Japanese industry had never attempted. More importantly, America had decided that speed mattered more than perfection. Traditional shipbuilding emphasized custom fitting, careful adjustment, zero waste. Every piece was measured precisely, cut carefully, fitted perfectly. Mistakes were avoided through skilled craftsmanship and meticulous attention to detail. This approach produced beautiful ships, but it was slow. Kaiser's approach accepted that some components would not fit perfectly. Some pieces would need to be scrapped and replaced. Some materials would be wasted. But the overall construction time would be reduced dramatically. When you had abundant steel, abundant materials, abundant labor, accepting 10% waste in exchange for cutting construction time in half was excellent mathematics. Japan could not replicate this approach. Japanese industry operated under material constraints that made waste unacceptable. Steel was precious. Every plate had to be used. Components were custom-fitted because rejecting a poorly manufactured piece meant losing irreplaceable material. This enforced craftsmanship, not through choice but through necessity. While Kaiser revolutionized escort carrier production, the fleet carrier program underwent its own transformation. The Essex-class program, which would ultimately produce 24 fleet carriers, began with traditional construction methods, but evolved rapidly as builders learned from escort carrier techniques. Newport News Shipbuilding in Virginia was one of America's premier naval yards, with decades of experience building everything from battleships to aircraft carriers. They knew carrier construction. They understood the complexities, the challenges, the time requirements. They had built USS Yorktown and USS Enterprise before the war, using conventional methods that took 30 months per ship. In 1942, With the Navy demanding carriers faster than anyone thought possible, Newport News began applying prefabrication techniques to fleet carrier construction. The transformation was remarkable. Flight deck sections that had previously been built in place were now fabricated in specialized shops. Complete flight decks, 800 feet long and over 100 feet wide, were constructed on their sides in buildings half a mile from the shipway. The decks were equipped with arresting gear, catapults, lighting systems, everything except aircraft. They were then moved to the ship on massive rail cars and lifted by the largest cranes in America. Propulsion systems received similar treatment. Each Essex-class carrier needed 8 boilers and 4 steam turbines, producing 150,000 shaft horsepower. Installing this machinery traditionally required months of work in cramped spaces deep in the hull. Workers had to lower individual components through narrow hatches, position them carefully, connect thousands of pipes and cables. Newport News created propulsion modules. Each module contained 2 boilers, 1 turbine, and all associated piping and controls. The modules were assembled in a dedicated facility, tested using temporary steam connections, verified for performance. When installation time came, the ship's hull had large openings cut in the sides. Cranes lifted complete propulsion modules weighing hundreds of tons and lowered them into position. Workers sealed the hull openings, connected the modules to each other and to the ship's systems. Installation time dropped from 3 months to 3 weeks. Similar innovations transformed every aspect of carrier construction. Radar systems were pre-assembled and tested. Complete radar masts with antennas, transmitters, receivers, and power supplies were built in electronics shops. They arrived at the ship as functioning units ready for installation. Crew accommodations were prefabricated. Entire berthing compartments with bunks, lockers, lighting, and ventilation were assembled in shops, then lifted into the hull as single units. The result was Essex-class, carriers that went from keel laying to commissioning in 14 to 18 months, roughly half the pre-war construction time. USS Essex herself, the class namesake, was laid down on April 28, 1941, launched on July 31, 1942, commissioned on December 31, 1942, 20 months from keel to commissioning. For a 33,000-ton fleet carrier with accommodations for over 3,000 crew, capable of operating 90 aircraft across unlimited ranges, the Japanese naval staff tracked Essex-class construction with growing alarm. 1 Essex-class carrier was notable, 2 was concerning. When the 3rd was commissioned, then the 4th, then the 5th, all within months of each other, Japanese analysts began recalculating their strategic assumptions. By December 1943, 11 Essex-class carriers had been commissioned, 11 fleet carriers in 1 year. Japan had commissioned 1 carrier, the Taiho, in that same period. The ratio was 11 to 1, but the shock went deeper than simple numbers. The Essex-class carriers were superior to Japanese carriers in nearly every measurable category. They were larger, carrying more aircraft. They were faster, capable of 33 knots sustained speed. They had better damage control systems, with extensive compartmentation, redundant systems, and trained damage control teams that could save ships from damage that would have sunk Japanese carriers. They had better radar, with Type SK air search radar that could detect incoming aircraft at 100 miles range, giving defending fighters time to intercept before attackers reached the fleet. They had proximity-fused anti-aircraft ammunition that increased defensive firepower by factors of 5 to 10 compared to contact or time-fused shells. They operated superior aircraft. The F-6F Hellcat fighter outperformed the Zero in speed, climbing rate, diving speed, firepower, and protection. Most critically, the Essex-class carriers operated as part of a system. They did not fight alone. American carrier task forces in 1944 routinely included 6 to 8 carriers, supported by battleships, cruisers, destroyers, all equipped with radar, all connected by radio networks, all operating from proven doctrine developed through years of combat experience. Japanese carriers by 1944 were increasingly kept in port, unable to operate effectively due to fuel shortages, lack of trained pilots. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. And the numerical impossibility of fighting American carrier groups with 3 or 4 carriers against task forces of 8 or more. The Battle of the Philippine Sea in June 1944 demonstrated the consequences of this carrier disparity in the starkest possible terms. Admiral Ozawa Jisaburo commanded Japan's mobile fleet, consisting of 9 carriers embarking approximately 450 aircraft. This represented Japan's entire remaining carrier strength assembled for one decisive battle. Against them, Admiral Mark Mitcher commanded Task Force 58, with 15 carriers embarking over 900 aircraft. The numerical ratio was less than 2-to-1, which seemed manageable. Japanese pilots, even the inexperienced ones now filling carrier squadrons, had always fought well when outnumbered. Tactical skill and fighting spirit could compensate for numerical disadvantages. Except the Americans also had radar that detected incoming strikes at 150 miles range. They had fighter directors who vectored defending fighters into optimal intercept positions. They had proximity-fused anti-aircraft shells that created lethal barriers around the carriers. On June 19, 1944, Ozawa launched 4 massive strikes against the American carriers. The Japanese pilots flew into a meticulously organized defensive system. American radar detected each strike while still distant. Fighter directors scrambled defending Hellcats and positioned them for interception. The Japanese formations encountered defensive fighters 50 miles from the carriers. The Hellcats, faster and more heavily armed than the Zeros, tore through Japanese formations with methodical efficiency. Of 450 Japanese aircraft launched that day, 300 were shot down. Another 50 crashed, attempting to land on carriers after dark. Japan lost 350 aircraft and their pilots in one day of combat. American losses were 29 aircraft. The exchange ratio exceeded 12-to-1, favoring America. American pilots, recognizing the one-sided nature of the combat, called it the Great Marianas Turkey Shoot. For Japanese naval aviation, it was catastrophic beyond description. Losing 350 aircraft in one day was unrecoverable. Worse, the pilots flying those aircraft were irreplaceable. Japan's training programs, already reduced from 24 months to 8 months due to fuel shortages, could not produce carrier pilots fast enough to replace losses from a single day's combat. 3 Japanese carriers were sunk during the battle. Taiho, Japan's newest and largest carrier, was hit by a single torpedo from the submarine USS Albacore. The damage should have been survivable, but a poorly trained damage control officer ordered the ship's ventilation systems turned on to clear gasoline fumes, spreading the fumes throughout the ship. Hours later, a spark ignited the vapors. The explosion tore the ship apart. She sank, taking 1,200 men with her. 32 months to build, 3 months in service, gone. Shokaku, veteran of Pearl Harbor, Coral Sea, and Santa Cruz, was hit by 4 torpedoes from USS Kavala. She sank 7 hours later. Hio was hit by aerial torpedoes and bombs, caught fire, and sank. Japan lost 3 carriers in 2 days. America lost none. By this point in the war, losing 3 carriers was catastrophic for Japan, but represented only a fraction of American carrier strength. The Americans operated 72 carriers of all types by June 1944. Losing 3 would have been tactically unfortunate but strategically irrelevant. The mathematics of carrier production had become so one-sided that individual battles no longer mattered. Japan could win tactical victories, sink American carriers, achieve local superiority. None of it changed the strategic reality. American shipyards were launching new carriers, faster than Japan could sink them, faster than Japan could train pilots, faster than Japan could produce aircraft to equip their own carriers. Captain Tomioka, standing in the Naval General Staff headquarters in March 1943 reviewing intelligence reports, had understood this truth earlier than most of his colleagues. The numbers told a story that military tradition and fighting spirit could not overcome. The initial calculation that America might build 40 to 50 carriers during the war had been wrong by a factor of 3. The actual number would be 124 carriers, commissioned between December 7th, 1941 and August 15th, 1945. Breaking down those numbers reveals the systematic nature of American production. 24 Essex-class fleet carriers displaced 33,000 tons each, carried 90 aircraft each, formed the striking power of the Pacific Fleet. 9 Independence-class light carriers, converted from cruiser hulls, displaced 11,000 tons, carried 33 aircraft, provided additional striking power. 77 Casablanca-class escort carriers, Kaiser's mass-produced convoy protection vessels, displaced 10,000 tons, carried 28 aircraft, provided air cover for amphibious operations and convoy escort duties. 14. Commencement Bay-class escort carriers, improved versions of earlier designs, displaced 11,000 tons, carried 33 aircraft, incorporated lessons from years of carrier operations. These vessels, commissioned toward war's end, represented the peak of American escort carrier design, plus various other escort carrier types and converted vessels, bringing the total to 124 carriers. Compare that to Japanese carrier construction during the same period. 6 fleet carriers of various types were completed after Pearl Harbor. Taiho, the 3 Unryu-class carriers, and 2 others, depending on how conversions are counted. 3 light carriers converted from other vessel types. 8 escort carriers of various designs, mostly conversions. Total Japanese carrier construction during the war was approximately 17 vessels, depending on classification criteria. The ratio was 7-1 favoring America, 7 American carriers for every Japanese carrier. But the raw numbers understated the actual disparity because American carriers were on average larger, carried more aircraft, had better systems, operated with better trained crews, and benefited from superior logistics that kept them operational continuously, while Japanese carriers increasingly stayed in port. The question that haunted Japanese naval planners from mid-1943 onward was not whether Japan could win, but how badly they had miscalculated. The initial estimate of 40 to 50 American carriers had assumed traditional construction methods, normal industrial mobilization, conventional shipyard operations. Every assumption proved wrong. American industrial capacity, once mobilized, operated at scales that Japanese analysts had calculated were physically impossible. The automobile industry's conversion to war production created manufacturing capacity that exceeded anything existing before the war. Ford's Willow Run plant alone produced 1 B-24 bomber every 63 minutes at peak output. That single factory produced more heavy bombers than Japan's entire aircraft industry, produced aircraft of all types. Shipyards applied automobile industry techniques to carrier construction, treating 30,000-ton warships as assembled products rather than custom-built vessels. The psychological impact on Japanese naval leadership was profound. Admiral Yamamoto Isoroku had warned before Pearl Harbor that Japan could fight successfully for 6 months, perhaps a year, after which American industrial power would prove overwhelming. He had been correct, but even Yamamoto had underestimated the speed and scale of American mobilization. By mid-1943, Japanese admirals understood they were fighting a war they could not win through military means. Tactical victories achieved nothing when strategic mathematics made defeat inevitable. Sinking American carriers was tactically satisfying but strategically meaningless when American shipyards produced replacements faster than Japan could sink them. Every engagement, every battle, every operation occurred against the backdrop of industrial capacity that made Japanese efforts futile. The human cost of this miscalculation was staggering. Japanese carrier pilots, among the best-trained naval aviators in the world in 1941, were systematically killed in combat through 1942 and 1943. By 1944, replacement pilots receiving 8 months of training instead of 24 months were being slaughtered by veteran American pilots flying superior aircraft. The Great Marianas Turkey Shoot killed 300 pilots in one day, none of whom could be adequately replaced. Japanese carrier crews, skilled sailors who understood complex carrier operations, died when their ships were sunk. Taiho took 1,200 men down with her. Shokaku's loss killed over 1,000 sailors. Each sinking eliminated institutional knowledge, operational experience, technical expertise that took years to develop. American carriers, with superior damage control and better defensive systems, were harder to sink. When they were damaged, they limped to repair facilities and returned to service months later with experienced crews intact. The strategic implications extended beyond carrier operations. The failure to predict American carrier production accurately was symptomatic of broader intelligence failures that plagued Japanese war planning. Japanese analysts consistently underestimated American industrial capacity, American technological innovation, American organizational ability, American national will. Every assumption about American society proved wrong. The belief that Americans were too soft, too divided, too focused on material comfort to fight a prolonged war was shattered by Pearl Harbor's unifying effect. The assumption that American democracy was weak compared to Japanese military discipline proved false, as democratic mobilization exceeded authoritarian mobilization. The calculation that American shipyards could not build carriers faster than Japan could sink them was wrong by factors that made the original estimates laughable. These intelligence failures stemmed partly from cultural prejudices that prevented objective analysis. Japanese military culture emphasized spirit over material, willpower over industrial capacity, tactical brilliance over systematic production. Officers who warned about American industrial power were dismissed as defeatist. Analysts who presented contrary evidence were ignored. The institutional culture rewarded optimism and punished pessimism, creating intelligence assessments that reflected what leaders wanted to hear rather than objective reality. Admiral Yamamoto had been one of the few senior officers who understood American industrial capacity firsthand. He had studied at Harvard from 1919 to 1921. He had served as naval attaché in Washington from 1926 to 1928. He had traveled extensively throughout America, visiting factories, observing industrial operations, studying American society. He returned to Japan convinced that war with America was unwinnable due to overwhelming American industrial advantages. His warnings were ignored by Army officers who had never visited America, and naval officers who believed Japanese tactical superiority could overcome material disadvantages. When Yamamoto was appointed commander of the Combined Fleet in 1939, he found himself responsible for executing a war strategy he knew was doomed to failure. His 6-month prediction was not defeatism. It was mathematical calculation based on understanding American industrial capacity that his colleagues refused to accept. His death in April 1943, when his aircraft was ambushed by American P-38 fighters acting on decoded intelligence, meant he did not live to see how completely his predictions proved accurate. By April 1943, American carrier construction had already exceeded Japanese worst-case estimates. By December 1943, the disparity was undeniable even to the most optimistic Japanese planners. The Battle of Leyte Gulf in October 1944 represented Japan's last attempt at coordinated carrier operations. The Northern Force, commanded by Admiral Ozawa, included 4 carriers with almost no aircraft aboard. These carriers served as decoys, intended to draw American carriers away from the main battle area where Japanese battleships would attack the invasion fleet. The plan worked tactically. American carriers pursued Ozawa's decoys. All 4 Japanese carriers were sunk, but the sacrifice achieved nothing strategically. American escort carriers at Leyte Gulf fought off Japanese battleships anyway. The loss of 4 carriers, which would have been catastrophic in 1942, barely registered in 1944 because Japan had no pilots or aircraft to operate from them. They were empty platforms, naval architecture without purpose, sacrificed in a desperate gamble that failed. Zuikaku, the last survivor of the 6 carriers that attacked Pearl Harbor, went down on October 25, 1944. She had survived 3 years of continuous combat operations, participating in virtually every major carrier engagement of the Pacific War. She was sunk not because of tactical failures or crew incompetence, but because Japan no longer had enough aircraft or pilots to defend her. Her loss symbolized the complete collapse of Japanese naval aviation, destroyed not primarily by combat, but by the mathematical impossibility of replacing losses against an enemy with 7 times greater carrier production capacity. By November 1944, Japan had no operational fleet carriers, 0. America had 98 carriers of all types operational, with more commissioning monthly. The disparity was so overwhelming that individual numbers became meaningless. Japanese naval strategy had collapsed into defending the home islands with land-based aircraft, while American carriers operated with impunity throughout the Pacific. The firebombing campaign against Japanese cities in 1945 was enabled by carrier air cover for B-29 bases in the Marianas. American carriers provided fighter escort for bombing raids, shot down Japanese interceptors, struck Japanese airfields to prevent counterattacks. The strategic bombing campaign that killed hundreds of thousands of Japanese civilians and destroyed Japan's remaining industrial capacity occurred under the umbrella of carrier air superiority that made Japanese defensive efforts futile. The atomic bombings of Hiroshima and Nagasaki in August 1945 were delivered by B-29 bombers. But those bombers operated from bases protected by American naval forces, including dozens of carriers. The entire strategic bombing campaign, conventional and atomic, depended on naval supremacy that carrier production had established and maintained. When Emperor Hirohito announced Japan's surrender on August 15, 1945, American carriers dominated every ocean and sea lane in the Pacific. Task Force 38, operating off Japan's coast, included 17 fleet carriers and 6 light carriers. Those carriers embarked over 1,500 aircraft, more than Japan's entire remaining air strength. The formal surrender ceremony occurred on September 2 aboard USS Missouri in Tokyo Bay, surrounded by American warships, representing industrial capacity that had overwhelmed Japanese resistance through sheer material superiority. The final accounting of carrier production reveals the staggering scale of American industrial mobilization: 124 carriers commissioned during 44 months of war. That averaged 2.8 carriers commissioned per month, sustained across nearly 4 years. At peak production in 1944, American shipyards were commissioning over 4 carriers monthly. Some months saw 6 or 7 carriers commissioned simultaneously. Japan's peak production was 2 carriers commissioned in August 1944. The Unryu-class carriers, Amagi and Unryu, completed within days of each other. This represented the absolute maximum output of Japanese naval construction operating under wartime conditions, with complete priority for military production. 2 carriers in 1 month was Japan's best performance. America routinely exceeded that by factors of 2 or 3. The lesson, learned catastrophically by Japan, was that modern industrial warfare was decided by production capacity as much as tactical skill. Military excellence, fighting spirit, tactical innovation, all the qualities that Japanese forces possessed in abundance, proved insufficient against an opponent who could absorb losses, learn from mistakes, and return with overwhelming material superiority. The initial calculation that America might build 40 to 50 carriers was not absurd or incompetent. It was based on reasonable assumptions about shipbuilding capacity, construction timelines, and industrial mobilization. What Japanese planners failed to anticipate was that America would revolutionize carrier construction, applying mass production techniques that had never been attempted for warships of that complexity. They failed to understand that American industrial culture emphasized speed and quantity over traditional craftsmanship. They failed to recognize that America possessed industrial depth that allowed simultaneous production of carriers, battleships, cruisers, destroyers, submarines, merchant ships, aircraft, tanks, and every other category of military equipment while maintaining civilian prosperity. Captain Tomioka, reviewing intelligence reports in March 1943, had seen the future clearly. The numbers told an undeniable story. Japan had already lost the war. The fighting would continue for another 2.5 years. Hundreds of thousands, more would die. Cities would burn. The atomic age would dawn at Hiroshima. But the outcome was decided by mathematics, steel, and welding torches in American shipyards operating 24 hours daily, launching carriers faster than Japan could comprehend, let alone counter. The wall map in the Naval General Staff headquarters, with its red pins marking Japanese-controlled territory and blue pins tracking American forces, showed an empire at maximum extent. Within 18 months, that map would show only the home islands surrounded by American naval forces that included more carriers than had existed in the entire world before the war began. The calculation error, the assumption that America might build 40 or 50 carriers when the actual number would be 124, represented one of history's greatest intelligence failures. It was a miscalculation measured not in percentage points, but in multiples, an error so large that it transformed a difficult, but potentially manageable war into an unwinnable catastrophe. Japan had bet everything on early tactical victories, forcing American negotiation. They had calculated that destroying the Pacific Fleet at Pearl Harbor would delay American counterattack for years, giving Japan time to consolidate territorial gains and establish defensive perimeters too costly for America to penetrate. They had assumed carrier losses would take years to replace, allowing Japanese tactical superiority to dominate Pacific waters. Every assumption was wrong, every calculation failed. Every strategic premise collapsed under the weight of American industrial mobilization, operating at scales Japanese planners had deemed impossible. The admirals who went silent when presented with evidence of 124 American carriers were not surrendering to defeatism, they were accepting mathematical reality. You cannot win a war of attrition against an opponent with 7 times your production capacity. You cannot achieve air superiority when outnumbered 10-1 by superior aircraft. You cannot maintain naval supremacy when your entire carrier force equals what your enemy produces in 6 weeks. The silence was recognition that fighting spirit, tactical brilliance, and warrior culture could not overcome industrial capacity measured in hundreds of carriers, thousands of aircraft, and unlimited trained replacements. The Pacific War's outcome was determined not on the flight decks, where pilots fought with extraordinary courage, not on the bridges where admirals made tactical decisions, not in the skies where aircraft dueled, but in American shipyards where workers who had never built ships before assembled carriers on production lines, welded steel plates with techniques borrowed from automobile factories, installed prefabricated modules designed by engineers who treated warships as industrial products. That transformation, invisible to Japanese observers until too late, rewrote naval warfare and demonstrated conclusively that industrial wars are won in factories long before they are decided in battles. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.